The purpose of this video tutorial is to show how to set up long-term deflection combinations for cracked analysis in Adapt Builder 2010 using the long-term deflection template. For this example, we're using a two-way conventionally reinforced slab. The first thing we'll do is we'll modify the load combinations. If we go to Loading, Load Combination, FEM, note that we have two default combinations, one service and one strength. We now need to add the combinations that will be used to perform the cracked analysis in Adapt Builder. We're going to be using the long-term deflection equation where we take 1 times the instantaneous deflection, or in this case we'll call this a sustained deflection, plus the creep factor times the instantaneous or sustained deflection, plus the cracked live load deflection. So to do this, we're going to go ahead and add a long-term deflection template. The program prompts the user to select the creep and shrinkage factor. Per ACI code, we'll assume that the load duration is more than 5 years. The 2 will be applicable here. If it's something different than or less than 5 years, you may want to use some lesser value depending on the code. So we'll go ahead and say OK. And note that 2 combinations are added to the program. The first is sustained load. It's set to a crack deflection analysis option, and this includes 1 times the self-weight plus 1 times the dead load plus some portion of the live load that might be sustained over the life of the structure. Here we've included 0.3. We also have a long-term deflection combination, which is essentially 3 times the sustained load, or the instantaneous or sustained load plus the creep factor times the sustained load. We also need to add another long-term deflection template to isolate the live load crack deflection. So we'll go ahead and say add long-term deflection. We're going to change the creep factor in this case to 1. And for sustained load, we're going to change this and call it total load. And for the live load, we're going to change the factor to 1. So we'll update that and save that. Now we need to go back and just delete the original combination. And for the long-term 1, we're going to call this long-term live load. And we're going to go ahead and select the different combination parts for this individual load combination. So we're going to include the total load, 1 times the total load, we'll update that. And we're also going to include 1 times or negative 1 times the sustained load. So we'll say negative 1, we'll add that, and we'll save that combination. And again, we're going to delete the combination that was originally created. So now we have 2 additional combinations. One is the total load, including all of the self-weight, all of the dead load, and the live load. And we have a long-term live load deflection. This includes 1 times the total load subtracted from the sustained load. So essentially this combination isolates the crack deflection due to live load only. The end result will be the sum of the long-term deflection plus the long-term live load deflection. This would equal the total long-term deflection for the structure. In order for the program to calculate the crack deflection, we need to design the rebar first. So we need to go through a complete design of this slab. We'll go ahead and mesh the slab. Under Automatic Mesh Generation, we'll say OK. We now need to analyze the slab, so we'll go to FEM, Analyze Structure. The analysis has been completed, so once the analysis has been completed, we're going to go ahead and generate the design sections for design. So under FEM, we're going to generate design sections. We now have sections for the X and the Y axes. If we want to view those separately, we can toggle between both the X and the Y. So now we're going to design these sections in order to get rebar for the crack deflection analysis. So under FEM, we're going to design the design sections. The design has been completed. We'll select Yes. And finally, we can go to FEM, Calculate Crack Deflection. And now the crack deflection has also been completed. To review the deflection results, we're going to go to the FEM View Results tab. And now we can review the deflections for the different load combinations that were assigned. Under Deformation Z Translation, if we turn on this light bulb, this displays the results in a graphical color contour format. So The loading in this slab is fairly significant. We can see just under regular service loads we have quite a bit of deflection, 2 and 2.97 inches. If we go to load case or load cases / combinations, we have multiple combinations. The first that we're going to review is sustained load. Now we have two combinations. We have a sustained load, which is essentially the uncracked state using I gross for sustained loading, and then we also have a cracked sustained load. So this value 2.05 is based on I gross. If we go to cracked sustained load, 3.82 is based on the I effective or some reduced stiffness due to cracking. So the cracked sustained load deflection is 3.82 inches. The total load deflection, uncracked, using I gross, is 2.97. Notice that this value actually equals the service total load value, which is the default load combination, because they are made up of the same components. The defaulted combinations in the program will always use I gross for the deflection calculation, so this is why those are equal. If we select cracked total load, we can see that the deflection is 5.93 inches. Finally, if we apply the long-term factor under the sustained load, we can select cracked long-term, so this applies 3 times the cracked deflection for sustained load, and that value is now 1.14 plus e to the 1, so 11.4 inches. And the cracked deflection due to live load, which is the difference between the cracked total load and the cracked sustained load, is the cracked long-term deflection for live load. So we'll go ahead and select that. This is 2.12 inches. If we compare this value 2.12 to the long-term live load, this is the live load due to I gross, it's 0.92. So there's some cracking just due to live load only. If we sum 2.12 plus the cracked long-term deflection of 11.14, this would give us the total long-term deflection for the structure. It's also important to note that for any cracked combination, whether it be sustained, the total load, or either of the long terms, we can review the cracking in the slab and the extent of that cracking. If we select the cracked sustained load, we know that this is cracking due to the increased deflection, and we go to the results, slab actions only. We can review the reduced rotational stiffness about the x-axis and also about the y-axis. So bending about the x-axis, these are the regions where the slab is cracking. We're showing the I effective over I gross ratio. The same can be done for the y-axis, and you can review these results for any combination where cracking has been selected as an analysis and design option. This will conclude the video tutorial on how to use the long-term deflection template in Adapt Builder 2010.